So today we will be going to talk about replication in Bevy. A little bit about me. My real name is Hennadii, and you may know me in Discord as Shatu and on Mastodon as well. Um, I work in at 45IQ as senior software developer, and it's not a game dev company, unfortunately. We develop tools that analyze hardware for vulnerabilities, but we use Rust. In my free time, I work on a live simulation game with a working title Project Harmonia. And I also maintain Bevy Replicon and Bevy enhanced input crates that I use for this game. So today, my talk will be dedicated to authoritative replication. We won't touch deterministic replication. Authoritative replication is when you exchange states, and deterministic replication, and it's where you exchange inputs and rely on determinism to keep the state in sync. Authoritative is just much more common because determinism is quite hard to guarantee. Everything in this talk will be related to client-server architecture, and we won't touch peer-to-peer architecture. It's because I personally a big fan of this decentralization, but peer-to-peer is not very common for game development, mainly because it requires more bandwidth, it's have more issues with NAT and firewall, and it also requires implementing hard consensus models. While with client-server architecture, the server is just always the source of truth. We will also touch client-side prediction, but only briefly because of short time period. And we also won't touch transports. It's the way bytes are actually transferred over the network. So in Bevy, you have several huge ecosystem. And of course, we have several networking crates to transfer bytes over the network. Example of such crates are on the screen. And I want to show you a quick example of how this API looks like. You usually have a message, which is an enum, and you just serialize it using CRD and send it to a client resource. On server side, when you receive, you iterate over connected clients and read bytes and just pass it into CRD again to get your enum and match the data. All these libraries have an API like this. But if you used Unreal Engine or recent versions of Godot, it's not the API you expect, because usually you have a much more higher level API, where you can just mark things for replication and it just works. And you can also call functions over the network. It's called RPC, which stands for Remote Procedure Calls. And I wanted to bring something like this to Bevy. When I started developing the crate, the ecosystem wasn't that robust. We didn't have Lightyear, and I found Naya, another networking crate, quite hard to work with. So I decided to implement my own. Originally, it was part of my game, but after some time, I decided to make it into a crate. So what it provides? It automates replication. It provides networked events and triggers. And it's also abstracts the game logic. It allows you to have single player, dedicated server, listen server, and with using the same game logic. It also doesn't have any I/O because, we already have plenty of messaging libraries. So I figured out that it would be better to just hook it into Replicon and support them. And it's also have extensive architecture. I provide a lot of API to implement high-level abstractions. Originally, the crate wasn't abstracted from I/O. It was using Renet, but after some time, I figured out that it's better to support multiple transports. And over the year, the library changed quite a lot. So let's talk about how it's implemented, actually. For some reason, animations on my slide doesn't work well. Okay, let me quickly display the whole slide. Okay, how to replicate the world? Simple. Basically, on both server and client, you want to decide which components you want to replicate, and then you need to decide which entities you want to replicate. Then on server, you just iterate or listen for server's entity spawn, despawns, components insertion, changes, removals, and resources. Bevy provides built-in mechanism for this, so nothing special is needed. And so we just utilized it. We also, in Replicon, we also don't listen for spawns separately. It's actually considered as insertions with 0 insertions, basically, just for optimization purposes. And right now, we don't replicate resources. That's because Bevy have plans to migrate from resources to singleton entities. I saw a PR from Alice for this, but we are not there yet. So just waiting for the decision. Okay, and on client, you just receive the message, deserialize it, map server entities to client entities, and apply changes. Mapping process is important because when you receive changes, you need to know to which entities you want to apply them. So when you first encounter an entity, you create an entity on client and have a special map that maps server entities to client entities and vice versa. Okay, let's talk about the tick rate. For some reason, animations on my slides aren't working properly. Interesting. Okay, tick rate. It's you don't want to send changes every frame. It would be expensive for bandwidth and would tank the performance. So we have special replicon tick resource that tracks a separate tick from Bevy's tick. And when this tick is incremented, the replication runs. And we have a special system that already increments the tick every time it runs. And it's configurable via server plugin. As you can see, in this example, I just disable this tick incrementation, and this way you can just schedule this system into fixed update, for example, and have a fixed tick rate. By default, it runs up to 30 times per second. So now we need to register components we want to replicate. Here's how it's done in Replicon. You can just call up.replicate and then put your components in here. Some components may contain an entity. And I mentioned previously that for replication, we need to map entities. And since component can also contain entities inside, we also need to map the internals of such components. But we already have a built-in trait for it. So we just utilize that and have a special method called replicate mapped, which accepts a component with map entities implemented on it. This way, entities inside it will be implemented automatically. But sometimes you want to customize the serialization. And this is why we provide replicate with. It's a special method that allows you to register a component with custom serialization and deserialization. This is quite useful when you want to apply things like compression, or you want to quantize values, things like this. And another option is to register a group of components. It's also quite useful. For example, you may want to replicate transform only for players and keep the rest of the world without replicating transforms. This way you can call replicate group. It's similar to how queries work in Bevy. For example, in this example, we have player and transform. And if these two components are present on an entity, only then they will be replicated. This way you can also customize how specialized realization for groups. For example, maybe for players, you want to replicate both translation and rotation. And for non-player objects, you may don't care for rotation. For example, if you replicate a ball, you may don't care about its rotation. This way, you can specialize serialization by implementing special trait. After that, we need to mark entities for replication. It's also quite easy. You just insert this replicated component, and that's it. The entity will be replicated. I previously mentioned that we don't replicate everything because, again, it would be quite expensive, and client probably already have the necessary meshes it want to display. So how to deal with such components? The answer is simple. Bevy recently introduced required components, which is just awesome tool for it. In this example, I create a player and assign mesh as a required component for it. Then I can just, as you can see, I inserted replicated in here because I want all players to be replicated. So I just mark it as required component, and all players will be automatically replicated. And then on insertion, I just create a special trigger, and I just listen for player additions or insertions, and initialize the correct mesh. Because I know, so for example, in my game, all players have specific mesh. So I know the exact mesh I want to initialize. That's quite convenient. If you have multiple meshes, you might have an enum, or you can transfer the path to the asset you want to load, things like this, and load proper asset in here. Okay, so moving next. Now, how to actually send messages, replication over the network? The thing is, messaging crates provide us with 3 channels: reliable, unordered, and unreliable. And when messages are transferred over the network, they are usually split by MTU. It's a maximum transaction unit. For Ethernet, it's usually 1,500 bytes. So the messages are split into packets, and the message is considered received only if all its packets are received. That's the way how messaging crate works. So how are we doing it internally in Replicon? Naive assumption would be that we can just use reliable channel because we don't want our updates to be missed, right? But it's not that simple. Let's take a look at the next slide. Here is the problem. If any packet is dropped, it gets resent with the same data. The issue with that is that when you do replication, you don't care about old values. Usually only interested in the recent one. Let's take a look at this example. On first tick, we have position X, and we receive it. We receive it. On the next tick, we might have different position, and we missed it. Packet didn't arrive. And on the next tick, we have a new position. And what will happen is that the backend will try to resend the position from tick 2 and a new position from tick 3. But we don't no longer care about the position that we had on tick 2. And this causes the problem. We just waste bandwidth for things we don't need. So we need some way to customize that reliability. How can we do this? Possible solution would be to just use unreliable channel and implement custom unreliability on top of it. If packet is missing, we can just resend with its up-to-date data, include up-to-date data, instead of resending the old value. But the problem is that its partial updates might break the game logic. For example, you might receive a component that stores, you might have a component that stores some entity. And after an update, this entity, it may point to a new entity. But the client might not receive this entity yet. And that's the issue, because when you receive such update, your game may just crash because you have a non-existing entity or entity without the components that you didn't receive yet. So the proper solution for this would be utilizing multiple channels. And that's exactly what we do. The idea is quite simple, actually. So basically, we send everything except mutations over reliable channel. Things like insertions, spawns, removals can be out of date. Even if you spawn and despawn an entity, your client might want to run some logic related to it, like, for example, count the number of deaths, for example. And for mutations, we use unreliable channel and always send the latest data. And but that's not it. Not only it. We also do some specialized splitting. For reliable channel, we don't do anything special. We just use a single message, pack everything in a single message because we don't want to lose. We don't want to apply the update partially. It would be weird if you replicate half of the world. That doesn't make much sense. But mutations are split into package size messages. So we try to pack them efficiently. And this allows us to apply mutations partially because they don't break the game logic. And to properly deal with partial updates, we assign a required tick for each mutation. So mutation messages rely on special tick on which they happened on server. For example, if there was a recent, so basically we just look for the latest insertion, removal, spawn, or despawn, and include tick when that happened to the mutation message. And mutation messages on client are both buffered until the update with this message is received. This way, we basically preserve archetypes. So this way, you can't receive an update. You can receive a mutation for non-existing that references a non-existing entity. So we preserve on the server state on archetypal level, but we also don't resend outdated information over the update channel. Moving next, I also mentioned that modern game engines have special mechanism called RPCs. It's because you can't just have only replication from server. You need some way of client to tell what clients wants to do, because we're not just watching a movie, we're playing a game, we want to interact with the server. And since replication happens only from server to client, we want some way for client to interact with the server. So basically, we have this remote events. From client events that are sent from client to server called client events, and the API is quite simple. You just register a client event like this, and you just send an event as usual, like this. I'm not sure if you can see my cursor. Anyway, on server, you receive the same event, but wrapped into from client structure. What is this from client structure? It's simple wrapper that actually includes information about client entity and contains the event itself. It's because on server, we want to know which client sent which event. This is why we have to use this wrapper for all our events. And we also have server events. They work in a similar way, but when you send the event, you not send just the event directly. You use this special wrapper called to clients, and this where you specify the mode of the sending mode. And on client, you just receive a regular event. It looks like this. This wrapper is actually quite simple. Bevy also recently introduced triggers, and they have a quite similar API, just like in Bevy. Triggers are basically a different way to trigger and react on events. The API just mirrors events in our case. Client triggers look like this, and server triggers look like this. Yeah, and also we have independent events, because internally all events are also buffered, just like updates, until the required tick is applied. Because you don't want to receive an event that references an entity that you didn't receive yet. But this actually can be disabled. This can be opt-out if you want to via special method. Okay, now I also mentioned that we can abstract over configurations. We have these 4 configurations. They are pretty common. Listen server, when the server is also a client. Dedicated server, when you just have only server logic client that don't have any authority over the changes, and single player when you just run the game without any networking. There are several approaches to this. Let's take a look real quick. So the classic approach is to separate client and server logic and run both server and client for a listen server. So basically, when the server I mentioned previously that listen server is when the server is also a client, and we just run both client and server for it. And single player is similar, but it's like listen server, but we don't accept any connections from outside. But there is a problem. Running both server and client in the same app would cause an infinite replication loop. It's because server, it's because we use change detection. On server, we detect changes, send it to client, and client applies the changes, which also causes change detection to triggers, and this would cause infinity replication loop even if you don't have any changes. So possible solutions would be to just use two Bevy apps inside a single actual app via separate threads, or two executables. It's quite simple. For example, in Terraria, you can host a game. When you host a game, it just runs a separate dedicated server in the background. But there is also another way, which I usually recommend, and it's on client, run only client and its logic. For dedicated server, you do the same thing, you run only server and its logic. For listen server, you run only server and both logic. And in single player, you don't run client nor server, but run both logic. And to achieve this, user just need to use run conditions. There is run condition called server on single player that is usually applied for systems that require authority. It's systems that usually deal damage, actually applies damage, systems that send server events or receive events from clients. And there are client and server specific systems that are used for miscellaneous things like display connection message, or on server, you may want to display a special menu that allows you to keep connected clients. And that's it, no special conditions needed for other systems. And in Replicon, we made it to just work. So user just need to carefully put run conditions and it will work perfectly. But I see that I actually running out of time, so I maybe not be able to tell how it works actually under the hood. So maybe Stefan, can you tell me? Can I continue, or are we running out of time?
Yeah, you probably have to cut it a little bit short, but if you're not talking about how it works under the hood, that would be kind of a bummer. So please give us an insight.
Okay. Let me continue. Quickly continue then. Okay, so here's what we do. For replication, it's quite simple. We just run send replication on dimension server running condition. It's special run condition we provide. And we receive replication only if client is actually connected. And we don't need to run receive replication when you are a listen server, because you already have all the data in your vault. You don't need to send it, or you don't need to receive it. And when you run single player, you actually don't need to send anything or receive anything. But I mentioned previously that for single player, you just don't need to run nor server or client. It should just work. So for replication, it's quite simple. We just internally put these two run conditions and it just works. But for event, it triggers. It's a little bit trickier, but I think it's quite a nice pattern. Basically, we just drain the events on client, and we just re-emit it as from client locally with a special server entity or server if server or single player condition returns true. And we do similar thing for client events. We just drain to clients and resend it locally at just here if the server is a recipient of this event. So I previously mentioned that you can run both server and client in a single app, but we actually don't need to do it because we can actually carefully drain and retrigger locally events and triggers locally. And replication actually don't need any special logic for it. That's it. This is why it just works in Replicon, and this is why I think it's quite simple. And then I have a quick a few slides about high-level replication. It's shouldn't take a lot of time. If you can give me a few minutes, Stefan, I can quickly skim straight.
Go ahead.
Okay, great. So how to exchange the data? Let's quickly take a look. So I previously mentioned that client communicates with server only using triggers and events. You can't replicate from client. Replication happens only from server. That's for security purposes. And the server usually replicates the state back. So clients, basically what we do, we client send event. Yeah, I want to do something, the server sends in the information back. But there are a few problems that may be important depending on the game you're making. If you don't replicate every frame, because I mentioned previously, it's expensive. So this introduces slight teleportation when you sync by position. And also, networking doesn't happen instantly. So it introduces some latency. To solve this, you can just interpolate the received state. If you don't care about latency, you can just interpolate the state and it will just work. Another possible approach, if you care about latency, the solution would be just to predict the simulation. But there is another problem. It causes mispredictions, because basically when you predict something on the client, you actually run in the future comparing to what server sees, because you apply the change immediately, and for server, it takes some time to reach. And this could cause things like, for example, player moves to point X, but player 2 actually stuns player 1. And how to deal with this? Well, the solution is simple. Actually, you want to, well, not that simple, but it's solvable. Basically, you receive the state when client receives the state from the server, it applies it and then resimulates starting from this state and replace all the inputs. There are two strategies about how much you want to predict. And for shooters, you want to predict individual entities, while for physics-based games, you need to predict the whole world. Just because you won't have a correct simulation if you want to do it. In Replicon, we provide an API for it. Basically, we provide client markers that allows you to override how components are written, and this way you can use it to override how components are written. For example, you can write not to the component directly, but instead use a special history component that you utilize in your interpolation or rollback rate, etc. We also provide text information that are also important for prediction. They are optional. You can disable some of this functionality because it's actually more. If you don't care about prediction, it would be a bit more costly to track this information. Because, for example, in order to properly decide, in order to properly know which updates were received, you need to send updates every time, even if you don't have any changes on the server, just send empty messages. But if you don't need prediction on rollback, you don't have to send these messages, and you can save some bandwidth. So we provide customization for it. And the last thing we have, here's what we have right now. Basically, for interpolation, we have a proof of concept crate called Bevy Replicon Snap. It allows you to interpolate your components, state of your components. We have a crate for entire world rollback, but it's in development. You may heard about it if you hang around in networking in Discord, in networking channel in Discord. And for shooter style rollback, we don't have anything. Yes, but that's only for Replicon. There are other crates that provide shooter style rollback. They are just not integrated with Replicon, such as Lightyear or Naya. And that's it. In the end, I just left a few useful links that might be, if you are interested in networking in general, you might want to check them out. That's it.
That was really a lot of interesting content. So I would cut the Q&A now to the two mostly rated questions, and then put the rest for the panel at the end. So did you benchmark the limits of the system, and what limits did you run into?
Honestly, I never benchmarked the limits. We have benchmarks. I always measure the performance, but I believe that replication will rarely be a bottleneck. Most of the time, it will be physics and things like rendering. You rarely run into performance issues with replication, at least with Replicon. It takes a few nanoseconds to replicate this stuff. We tried so hard to make it as optimal as possible.
Cool. And the second one, you mentioned Bevy Lightyear. So what would be the quick difference between the two? What can you do that Lightyear can't, and the other way around?
Well, Lightyear is like transport messaging crate plus Bevy replicon plus high-level rollback crate and plus possible lag compensation crate. So Lightyear provides everything in a single package. Lightyear also have the mentioned high-level functionality like client-side prediction and interpolation. We don't have a really mature crate for replicon yet. So if you care about prediction, I would highly advise to check Lightyear. But if you don't care about prediction for your game, I would recommend to check Bevy replicon because it might be more performant. But at least based on what I saw. So Lightyear more focused on features, while Bevy replicon is more focused on performance and extensibility. So you can extend on things on top of it. I also mentioned previously that there are two possible ways of how to roll back the several individual entities and the whole world. And Lightyear implements the individual entities approach. So if you you aren't building a physics-based game, it should be a good fit for you.
Mm-hmm. Interesting. Okay, cool. Hennadii, thank you so much. That was super interesting. Big hand from chat, please, for this presentation. I'm super curious about the networking crates that we have in Bevy myself. So this was super interesting to me personally as well. Thank you so much for being here, and see you at the panel conversation at the end again.
Thanks.